Next, we're going to move into a topic called statistics and parameters. A couple of definitions to get us started. Basically, what a statistic is it's just a measure that describes a characteristic of some large sample. A parameter is a measure that describes a characteristic of an entire population. Remember, samples are smaller than the population. One thing we need to note, statistics are going to change depending upon the sample. So the small portion you take may change the general statistics you're calculating, but parameters, those don't change at all because the population is the population. It's the large group of things, and those you never take a subset of. So let's move forward with this. So what we want to do in this first example is identify the sample and the population for each situation. Again, the smaller part of the larger part. And then describe the sample statistic and the population parameter. So we have a situation where a movie rental business selects random sample of 50 orders in one day, and then they find the median of the number of rentals per order. So if we want to take and identify the sample and the population, we're looking at the following items. The sample is going to be 50 movie orders. That's the smaller part of the large. The population in this piece is going to be all the movie orders for the day. The sample statistic is going to be that median number of rentals per order in the sample, and the population parameter is the median number of rentals for all the rentals at that place in one given day. Let's do another one just to get a hang of it. So we're describing the same two things. In this case, we have a stratified random sample of 2 trees of each species is selected from all the trees at a nursery, and we're going to look at the mean heights of the trees in the sample. So if we want to take the smaller and the larger, the smaller is the 2 trees of each species found at the nursery. The population is all the trees in the nurseries. The sample statistic, the statistic of the small part we're taking, is the mean height of the trees in the sample, and then the population parameter is the mean height of all the trees at the nursery. Now we're going to take a look at a couple of different calculations for samples and populations. One is called the mean absolute deviation, or MAD for abbreviation. And what that is, it's the average of the absolute values of the differences of the mean, that's the average, and each value in the data set. And what this calculation is used to do is predict errors and judge how well that mean number, that average, describes the data set. So in order to do this, if we were to do it by hand, we'd take the mean of the data set, so we'd add up all the numbers, divide by the number of numbers in the set, then take the absolute value of the difference of the mean. Mean is x bar, so that's this guy right here. That's the mean. And x sub n refers to each element in the sample, so each number in the sample. Then find the sum of all those differences and then divide by the total number of numbers. All right. Now, luckily for us, our calculator is going to do this for us. So let's go ahead and do that on a calculator. All right. We have a set of numbers here, 14, 18, 12, 17, 15, and 20, and we're going to calculate the mean absolute deviation. So again, let's get our calculator out. You're going to take and hit Stat, Edit, and we'll plug in the numbers in that list of 14, 18, 12, 17, 15, and 20. From there, we'll quit, move over to Stat again, go to Calculate, hit one variable statistics, and hit Enter once again. And notice we'll get an average of 16. So let's just write that down. X bar equals 16. And remember, that's the average. So now once we have that average, what we're going to have to do to calculate this absolute deviation is we're going to have to take this average, subtract each number in the set from that average, take the absolute value, add all those numbers up, and divide it by the total number of numbers in the set. It's a lot to do, so we're going to let our calculator handle this for us. In order to do that, we're going to have to go back to stat. We'll go to edit again. Rather than typing down in this column, we're going to actually move up to where it says L2. And we're going to have to take the absolute value. So to do that, we go math, num, hit the number 1 or just enter for absolute value. Then from there, we're going to take this average. We have to actually type that in, so 16. And then we're going to take from that each number in this data set right here. So rather than type all those numbers over again, we're just going to say second, and then go down to 1, and you see above that there's L1. And what will happen now is in this list 2, I will get all the absolute values of the average 16 subtracted from each of these numbers. So now if I go down, notice what happens. If I had 16 minus 14, I get 2. 16 minus 18, I get 2. And these are absolute values, 16 minus 12, 4, etc., etc. Then from here, what we're going to do is we need the average of all these. So we're going to go back to stat after we quit out of this list. And we're going to move over to calculate. We're going to hit one variable statistics again. But instead of just hitting enter, we're going to go second and L2. And hit enter. And what we get is we get 2 1/3 or 2.3 repeating. And what that is that's the mean absolute deviation. So that indicates, on average, the number of monthly pets adopted each month is about 2.3 pets from the mean. So that's not a giant spread, is what that's telling us. Now, the mean absolute deviation is one number that describes the spread of numbers from that mean. The most commonly used number to describe that is something called the standard deviation. And this number right here, or this symbol, is a symbol for standard deviation, and they call it sigma. And sigma notes the standard deviation, which basically tells how the data deviates from the mean. Low standard deviation means the data is not very far spread from the mean. High standard deviation indicates the data is spread over a large range from the mean. The standard deviation squared is something called variance. To calculate the standard deviation, again, you can see it's quite a lengthy calculation. You have to find the mean, take the square of the difference between the mean and each number in the data set, add everything up, divide by the total number of numbers, and then actually take the square root of that. So there's a lot of steps involved. Unfortunately, our calculator will do that again for us. So let's go ahead and get started. So in this example, we've got a kid tracking homework scores from the past week. Gets 100, 0, doesn't turn that in, 100, 50, and 0. And we want to interpret the standard deviation of this data set after we find it. So let's go ahead and get to our calculator. We're going to plug these numbers in. So I've gone to stat, edit, plug those numbers in. Now, one of the calculations that our calculator will do under one variable statistics is the standard deviation. It's a commonly used calculation. So if we quit out of this, hit stat, calculate, one variable statistics. Remember, if we just hit the one variable statistics and then enter, it will go right to list 1. So we notice that our average is 50 in this case. And let's go back to that screen again. Right here is our standard deviation. and that was about 44. So what that says is it says, after doing this calculation here, taking the difference of our average and each of our numbers, adding all those numbers up, dividing them by the total number of numbers, and taking the square root, we get a number of 44. Now that's a high number, which means the average of all the distances away from the average of all these numbers is very high. So these numbers are all spread out. They're not really closely related to the average. And our answer states pretty much that. A large standard deviation suggests that the data deviates quite a bit from the mean. So Leo's scores far away from this mean of 50 indicate that the data is not compact. Let's take a look at this next example where we've got some information about left-handed and right-handed throwers. And below are the speeds in miles per hour of 16 throws from each guy. We want to compare the means and standard deviations. So what we're going to have to do is set up a couple of tables on our calculator. So let's go ahead and do that. So once again, go to Stat, hit Edit, and I've already plugged in the numbers. So if you go to L1, and if there's something in it, again, just move up and hit your clear button from there, and it'll clear that entire list out. Type in all the left-handed items here, and then in L2, go ahead and type in all the items from the right-handed thrower. And now we'll go ahead and calculate, once again, the mean and the standard deviation for both. So let's set up a column for that. Here's the left-handers, and then we'll set up a column for the right-handers. Hit our average, and then our standard deviation in both cases. Go back to our calculator. We'll go Stat, Calc. We'll go one variable statistics. We need to tell the calculator which list to take that from. So we'll go second L1. And we have an average here of 69 points. I believe that was 68. And then we had a standard deviation of 2.19, basically 2.2. And then let's go over and calculate the information for the right-handed column. We'll go quit out of this, go Stat, calculate, again one variable statistics, but in this case we're going to do it for L2, second L2, hit enter, and in this case we get an average of 76.75. Take a look at the standard deviation. It's about 5.33. So let's take a look at these two numbers and just talk about them, and then we'll take a peek at the answer. Lefty throws a lot slower, but his standard deviation is lower, which means the average throw away from 69 miles per hour is somewhere around 2.2 miles per hour. So a lot of his pitches are within the same speed. The righty throws quite a bit faster. He's got a standard deviation of 5, so his speeds of pitches vary greater. So depending on the kind of thrower you want, you may want a guy that throws constantly, the same speed, or you might want a guy who changes things up. You never know. Let's look at the answer, and says left-hander throws with about 69.7 miles per hour, standard deviation of 2.2. Right-hander throws average 76, standard deviation about 5.3. And the right-hander throws average higher speed, but also has greater variability within speeds, which is what we kind of talked about before. So that's all we've got. Here's a couple questions for you to answer. First one, find the mean absolute deviation. Second problem asks you to find the means and standard deviation and do a little comparison. Both of these are multiple choice, so you can calculate it and then take a look at the two answers. And that's all we've got.